they have this like chessboard set up. The stage is vertical. There's like a dozen people on the top, a dozen people on the bottom, and they come at each other. And then when they fight, they float off. And it really was like the Matrix, slow motion, exaggerated motion, but
live.
The floor is vertical. But because humans are, there's just something weird about us humans. You can watch this vertical floor and the people fighting on the vertical floor, and it stays vertical in your mind, but you very quickly accept it as a horizontal battle sequence.
Holy crap.
You're watching it and you're amazed the way it plays with your perception. But again, to play with your perception like this, they had to create a stage 50 foot long by 25 feet wide, pick it up 72 foot 9 inches in the air, spin it at 2 RPM through infinite rotations and tilt it 100 degrees.
That's crazy.
Welcome to Collaborative with Spencer Krause. This is a place for accomplished professionals to talk about their life and their work in an informal and hopefully an insightful way. If you like what you see, hit subscribe below. Enjoy the show.
So welcome to the Collaborative Podcast. I'm your host, Spencer Krause. Our guest today is Stephen Sywak. He's a mechanical engineer that's done way cooler stuff than me in a lot of ways. And welcome to the pod, Steve. Good to have you here.
Thank you very much. This is my first podcast as a guest, but I've never done one as a host. So my very first podcast.
Nice. Yeah, it's about my 14th. So
Cool.
I'm fairly fledgling to it too. I'm sure we'll be doing this again in a year or two. And,
yeah. All I ask is please be gentle.
I mean, I just try to be nice and talk to people here. The whole thing is intellectual discussion and then just kind of, probing questions and then informal. So kind of the stuff you and I talk about anyway, but just for an audience basically. And then we try to make it so if there's anything somebody wants edited out, we let them, and then people stay relaxed, and it's like.
So if I say anything legally incriminating, you can just splice that out and.
Yeah, we can do that. I mean, it's if you say every other word legally incriminating, we probably have to scrap it because then it gets to be expensive to edit.
I know myself. There's a chance I may curse here or there, but I'll
usually like a couple of swears isn't a big deal on these. Okay. So I mean, it's.
I'll try to keep it PG-13.
Yeah, it's so you get like one fuck and then a couple of shits.
There you go.
And, that's
you've already broken the ice.
I've just spent the magazine. Yeah, exactly. So
all right. So I guess I will let you.
Yeah, sure. So just to kind of ask about your work, and this is something that I've seen and I was impressed by. I got to say I was kind of in awe. So we met at an ASME event, I think, where I gave a talk, and then you said this reminds me of the stuff I did in entertainment, and I was like, oh. What'd you do in entertainment? I've done some stuff there too. And then we just started bonding and telling war stories. And I was just like, I'm going to be friends with this guy. So, we recently had like a storytelling contest just to kind of rein it in more. And you posted a video of Morgan Freeman talking about your work. And it looked like he was confused.
The 6-foot-thick sand cliff deck has a 25 by 50-foot touchscreen projection playing surface. We fire 80 pegs, which serve as handhelds for the acrobats. The tatami deck can slide forward 46 feet at full travel, like a giant drawer slide. At its full extension, it appears to float over the abyss.
So I don't know if you want to talk a little bit about that, and then we can kind of go.
Yeah, well, years ago, over probably 15 years ago, was when we first got the request for proposal in from Cirque du Soleil and the MGM Grand over in Las Vegas for a new, very crazy show that they wanted to put together called Top. Cirque had been around for a while, and I was working at a company called McLaren Engineering Group,
cool,
which was in West Nyack at the time, and now they're in northern Jersey. I forget the exact town, but they had an entertainment group within the larger engineering company. And so we started getting, contacts from the police knocking on your door there.
No, I just thought I saw the kitchenette fridge door open or heard something, but it was nothing. So I was checking the door to make sure my fridge wasn't defrosting.
We started, conversations with Cirque and with MGM. I mean, my sense was that Cirque was really leading the charge. About how could we design this show for them, and it was being designed by a guy named Mark Fisher, who passed away 2014 maybe, but he ran Stewfish Studios out of England.
Oh, cool.
He did he designed The Wall, Pink Floyd and later
that's
Roger
awesome.
Waters, The Wall concert, the tour, a number of Yes tours. Amazing guy. His group does amazing stuff. The group still exists.
Yeah,
unfortunately,
big fan of that show.
He no longer does.
Unfortunate.
But one of the nice things about him is was one of the few production designers who understood the laws of physics. And if he didn't fully understand them, he at least knew that they were a limiting constraint on his concepts. Sooner or later, they would be the limiting constraint.
Smart.
And so he was not offended if we asked him if we could please work within them. He was good on that. But he also, he was an excellent blend of it, because he really brought things to the edge. He was always sort of balancing on the edge of could it be done or not.
Yeah, but still within the laws of reality, which is not always the case.
He knew that they were out there, and he sort of paid homage to them as he walked by them. But he was okay if we walked him back a little bit. And it was really nice working with him. But he and his group came up with a number of they did a bunch of work, computer design, computer graphic design. They did some computer animations like you would have with an animatic or a storyboard for a film production.
Oh, cool.
And a lot of multiple points of view of the show as they were perceiving it.
And that informed your mechanical design.
Beg pardon?
I said, and that storyboard and that animation informed your mechanical design?
That got us started. They wanted, there's the final show, which is put on hiatus due to COVID. But my understanding is that Ka will be returning.
Very cool.
Some other Cirque shows like Zumanity, which I also worked on, is not going to be returning.
Did not know that. That's awesome.
But Ka will be. But Ka had a number of main pieces. They had a large central stage that was eventually called the Sand Cliff Deck. And so there was the main stage. There was a secondary stage called the Tatami. And then there's a number of other effects. Some remained in the show, some got canned, some got in essence bolted onto the Sand Cliff Deck. But the original concept of the Sand Cliff Deck was like a giant cherry picker robotic arm, a pivot at the base, a pivot at the wrist, and an extension axis in between. So it would go here. You would You would hold the deck. The deck could rotate, infinitely around. You could pivot it. It would have a base. It would go like this, and then this whole section here would extend.
Okay, so 4 degrees of freedom then?
At least I think the deck not only pitched forward and back, but was originally designed to wobble left and right.
Was the extension on another gimbal, or was that just stationary?
The extension was on there was azimuth, so it would go up and down. So that's axis 1.
Okay.
Axis 2 was the extension.
Cool.
Axis 3 was the wrist pitch.
Cool.
Axis 4 was the wrist
yaw, I would think.
yaw, and axis 5 was the wrist roll.
Cool.
That's a lot of, and I've been involved in robotics since getting out of college.
Nice.
And I worked on some large scale robotics for the space station, for NASA, while working at Grumman. Worked on gimbaled platforms for the military while working at Aeroflex in Plainview. A gimbal is like, because not everybody knows, a gimbal is like what you see holding a gyroscope. It's a pivot. It's a pivoting ring inside another pivoting ring inside another pivoting ring. Those pivoting rings are gimbals. So, I was very familiar with how to actuate them, pluses and minuses, limits, restrictions. And our first design tried very hard to give Mark Fisher what he was asking for. And it proved to be very difficult. So we took a very close look at the animations he gave us. And we told him, and we actually, at McLaren, we modeled a simplified, we early on got rid of the yaw axis from the wrist, because that, to us, that seemed like a huge amount of complexity for very little benefit based on the storyboards and the animations we had seen.
Yeah, that makes sense.
So, we knew we needed to keep the roll and the pitch at the wrist, and we knew that he wanted the deck to move up and down. But when we looked at the animations, the deck never really moved. This is the audience here, let's say. The deck never really moved this way, upstage, downstage.
Yeah.
And so going through his animations, we said, first off, we've modeled your piece roughly as you've designed it, and the amount of power and torque and horsepower
must have been astronomical
that it requires are immense. And I don't think that it's practical. But we then modeled an alternate approach, which is a giant H frame made out of a 6-foot diameter steel tube.
Holy crap.
So we had a central steel tube with giant bearing blocks on the end.
6 feet in
the
diameter.
The tube was 6 feet in diameter. It ran up and down on 2 4-foot diameter steel tubes with special bearing tracks. And it was still monstrous.
Yeah, it sounds like it.
But we ran the numbers. We did some rudimentary stress and strain calculations. We did horsepower calculations, and we said, we think we can achieve this. It changes what you've drawn, but looking at your animations, I think it gives you 80-90% of what you're looking for. And most importantly, we can achieve this.
Yeah.
So we changed the design of the show, is what we did over at McLaren.
Makes sense.
I like to think that I changed it, and maybe I did, but I think I'm just showing my ego. McLaren changed it. As a group,
but I mean, if Mark Fisher was in the loop and it was his design and he was okay with it, it just sounds like a collaboration.
Since he's unfortunately no longer with us, I can say anything I want, and he's not there to contraindicate me. But it was a team thing. It really was. I mean, the project was of such a giant scale. It was hundreds of people on the team to make it happen. So we designed it using that system. We wound up using 4 of what we think are probably the world's largest hydraulic cylinders that were custom built for this show.
Nice.
They have, and here it is 15 years later, I still remember most of the specs. 72-foot 9-inch stroke, 5-inch rod, 12-inch bore. Each cylinder, there were, as I mentioned, there's a left column and a right column, and then there's an upstage.
What's
and a
the rod
downstage.
versus the bore in a cylinder? Just so I'm
understanding. If this is a cylinder, this is the rod.
Okay.
The rod comes in and out of the cylinder, but inside the housing, inside the tube, is a piston. The piston, like in a car, is attached to the rod, rigidly attached to the rod. And so as you put oil pressure on one side or the other of that piston, you move the system.
And the diameter that rides within is the bore.
What?
And the diameter that rides within is the bore.
Yes, the OD of the piston, which is within a few thousandths of the ID of the cylinder it's in, that's the bore.
Got it.
So if you have a car with a 2.5-inch bore, we have a hydraulic cylinder with a 12-inch diameter bore.
That's insane. That must have been astronomically expensive.
It was. We ordered
87-foot stroke, you said.
We needed 4 cylinders for the show, and we needed I said, you really want to buy a spare.
Smart.
I said, if a cylinder should fail,
Yeah, good luck
to
with the
send
lead
the
time.
cylinder out to get it refurbished will kill you for months. To order a new cylinder will kill you for months. You want to buy an extra cylinder and wall it up in the building somewhere so you're not tripping over it. So somewhere at the MGM Grand Theater is this, I think they were like rough numbers, $750,000 each,
Holy
maybe.
crap. That's insane.
And somewhere is a $750,000 cylinder that's still walled up. And hopefully there's a sign on the wall that says, break through the plaster in case of emergency. There's an extra cylinder in here.
That's incredible.
But the cylinder is as ridiculously large as their components were. A 5-inch diameter steel rod, solid steel.
Yeah, that's crazy.
The cylinders are so long that when you calculate the stability of a structure, particularly in compression, there's something called the slenderness ratio, which has to do with the end fixity, has to do with the length, and has to do with the way it's constrained at its end. Well, the end fixity and the length and the bending moment of inertia of the cylinder.
Yeah, and you've got an 87-foot stroke.
72 foot 9.
Sorry. Okay.
But that's fine. That's fine. The cylinder was slender. The rod was slender. The rod could not take a compressive load. Period.
Wow.
Could not take a compressive load. It would.
You can only load it in tension.
It could only work in tension. So it was like a rope that way. It was a 5-inch diameter steel ingot rope. The stroke was so long they couldn't chrome plate it.
Seriously.
Which is typically what you make with a cylinder. They said, we can't chrome plate
So you said
it.
to grease it constantly, I'm guessing.
We'd friggin' kill the earth with the chemicals, and nobody has a bath long enough to handle this rod. So certainly in America, in the North American continent, because it was built by Parker Hydraulics.
Oh, cool. Yeah, they make good stuff.
And if Parker Hydraulics which is one of the major players in hydraulics across the world,
Yep.
if they had no way of chrome plating this rod, I would say Parker never made a cylinder that big until we asked them to.
That's awesome.
And the company on Long Island that helped us do a lot of the hydraulics, Atlantic Industrial, I've remained friends with some of their guys. And the head of the company, years after the show, said, I want to thank you for selecting Atlantic because you helped put both my kids through college.
That's awesome. I gotta love the honesty of that.
Yeah, but so we had this giant cylinder, and the cylinder was like, a 6-month turnaround, roughly, maybe 8 months, I don't remember, but not a quick turnaround. No off-the-shelf parts whatsoever.
Yeah, I believe that. Everything was probably machined just for that. And then I would imagine the machine tools were incredibly scarce,
Yeah, so
where do you find a lathe that size?
Parker makes, maybe the cylinder, the piston itself was available because 12-inch is a catalog part and 5-inch rod is a catalog part.
Interesting.
Nothing at this length. We had to design special constructs to ship.
Were there weld marks on it anywhere, like heat treating? I wonder.
You know what? I never really got a close view of the cylinders.
Oh, that's fair.
But so we had to order the cylinders before we had completely designed the rest of the show.
Yeah, it makes
which
sense.
Was scary. We had to pull the
But
pin.
you're constrained, yeah, because now you got to stick with that stroke, or at least
So it's like,
can't go higher.
The thought was, and to keep them from being over constrained, as an engineer, when you model a system of constraints to do an analysis, you have degrees of freedom that you constrain. So I have, let's say this is now the cylinder body, and here we go. Let's see if I can do this. So let's say that this pen is a cylinder body, and the ink piece is the rod.
Oh, cool.
We had to hold the cylinder at the bottom. We had to hold the cylinder at the bottom, but we couldn't constrain it against rotation because then we could over-constrain the rod and damage the rod.
So there was another gimbal I had to ride on.
We put it in a giant half-spherical bearing.
Oh, cool.
From Hunger, out of Germany. The bearing was probably 16, 18 inches across.
That's awesome.
So we had to keep the cylinder from rotating. So we machined a pin into the system and a fork for the pin to rest in and a spherical bearing. And it was an idealized free-moment connection.
Free-moment connection?
There was no moment. There were 2 out of the 3 moments. There's three linear actions and 3 rotational actions that, like when you're constraining parts in a CAD assembly, when you're putting together pieces in CAD and you have to take the shaft and put it in you have to constrain against X, Y, and Z linear, X, Y, and Z rotation.
Got it.
So we had to free it up in 2 degrees of rotation. So it could go like this and go like this, but it couldn't go like this because we tear the hoses off. And so we put it in this giant spherical bearing with an anti-rotation pin, which looked like the most ridiculous thing, but it's like, it solves the problem. And because the cylinders could never go into compression, we never had to worry about being unseated from the ball and socket joint. We could never go like this because the cylinder could never go into compression by definition.
Yeah, so I'm guessing you'd even hook up that axis.
So
Not that
we could have gotten a full spherical bearing,
Yeah.
but we got a half spherical because it handles better axial loading.
Yeah.
Because each cylinder nominally handles 75,000 pounds of tensile load.
That's insane.
That's the resting load of the system. The
What's the
crossbar, the stage, the payload on the stage, and all the crap and hydraulics and other things on that mechanism that moves up and down weighs about 300,000 pounds.
Holy crap.
150,000 pounds per side, 2 cylinders per side, 75,000 pounds per cylinder, minimum of 2-to-1 factor, minimum of 2-to-1 capacity, not even talking about factor of safety. The 1 cylinder on each side would be capable of lifting its share of the load.
Cool.
So 1 cylinder could pull 150,000 pounds if it had to.
Nice.
Because there were people on it. There were
Yeah. You can't mess around.
80 people at a time on this thing, and it's like there aren't that many specifications that we had to adhere to, but we were all professional engineers, and we had to think, okay, it's got to be safe as anything. I wouldn't even say safe as driving a car. It had to be safer.
Wow. Yeah, because 80 people. I mean, I'm guessing
80
that
people. If that takes a dump with 80 people on it, none of them are tethered. There are sequences when there is no safety airbag or net below them.
Wow.
We had at least four giant shock absorbers that stood probably 4 feet, 5 feet tall in the basement that would react against the system should it fall unconstrained.
Wow.
But, we had the world's largest fin brakes, which we then improved upon. I remember the name of the Hilliard fin brakes, the sort of brakes that he used on mining cars that go down the mine shaft that will protect the miners from death. We used 2 of those, and we improved its frictional capacity.
Nice.
For reasons that are part of another story. So we had these Hilliard Twiflex fin brakes that were monsters, but just in case, in the bottom 6 feet or so of travel, if the hydraulic system should totally shit the bed, it would then fall and the brakes couldn't kick in time. It would fall onto these shock absorbers and absorb all the momentum and all the potential energy that it converted into kinetic energy.
I'm guessing those were only ever used in testing.
I don't even think they dared test them. I don't think they had the nerve.
So like an engineer.
And I was not about to be the one to say, you know what, you should really test those.
Yeah, and then it's like a $5 million error.
Yeah, but so we installed the system. We had a mechanical tilt indicator bolted to the back of the cross tube, where an
Like a level?
inclinometer, an instrumented inclinometer. So if the thing tilted, it would trigger and shut the system down. One of many safety systems.
Very cool.
But going back to an earlier part, so we had to design the cylinders and specify the length of the rod, but we also knew that because we were going to be using force-compliant control on the world's, oops, no one saw that.
You missed the keyboard, so I'm good.
You can edit it out.
I think I'll leave it in.
Since we knew in advance that we were going to be using force-compliant
yet.
control on these 4 cylinders, we knew we had to include strain gauges. There are companies, StrainCert is one, though I know we didn't use StrainCert because they're expensive. I cannot remember the name of the company we used, but they made a 5-inch diameter hunk of stainless steel.
Oh, that's cool.
That mimicked the female, whatever the thread was we had on the end of our monster cylinder.
Yeah.
We had a female on the top and a male reproduction of it on the bottom.
It's just like Series Elastic.
Those were like a 4-week turnaround.
Nice.
So as the design progressed, we finally settled in on the exact length we needed for the cylinder rod.
Oh, cool.
And we just told the strain gauge people how long to make their insert to make up whatever distance we needed to make up. And it was perfect.
Nice.
It was such a wonderful solution. So we had strain gauges, and the strain gauges fed back into the control system, both for servo control, and we found a special company, RG Group, down along the southeast coast of the U.S. to upgrade a system they had done for the die press industry, a force control system for much smaller systems. We had them remake their system for us because we had to have individual valves for each of these giant cylinders, both because we didn't want, if the hose blew, if we had one valve for 2 cylinders on a side and one hose blew, we'd lose control of both cylinders.
Yeah,
and
makes
we couldn't
sense.
recover. So, and we ran the risk of the system dropping. So with independent valves, servo
You've got
valve
redundancy, and you can lose one and still not lose control of the system.
Right. So that's what we did. And also the volumetric flow rates were insane, as you could well imagine. So to have one valve handle that would have been nuts. But to split it into 2 parts made it work. So
Nice.
we did that. It worked. So the strain gauge information, the tension load in the cylinder rod fed back into the control system, but it also fed into a safety system. We had a trigger if the tension should go below some set point.
So you were
So
tensioning
these
it
things-
against itself, kind of, since you were doing it.
Well,
Okay.
if your system needs to be at not only 75,000 pounds per rod, and let's say you're lowering and you hang up on something or you bind somehow, and your tension starts to fall away.
Yeah, it makes
From
sense.
75,000 pounds tension to 70, 65, 60, 50,000 pounds of tension, that's still a lot of tension, but it's heading towards 0.
Yeah, it makes
And
sense.
then it's heading into compression.
Which, yeah, you already told me what would
They
happen.
had a tension set point where if the tension should fall below some preset value, and I don't know what the value was, it would again shut the system down, shut the show down, because you were headed towards trouble.
And breaking everything, it sounds like.
Yeah. But when they first got things set up, they had to use a giant crane to take these giant cylinders and bring them into the theater from above and lower them in.
I would imagine they would need that again if they had to ever pull that one out of the wall.
Yes, they would. But there's always construction in Vegas, so there's always a giant crane nearby.
Touche.
But two things happened. One, they dropped a cylinder.
Fuck.
And I think many pants were shitted that day.
Shat.
but we they had people on site examine the cylinder. We took a look at it. It was fine. And
I think the crane operator felt when that happened. I would imagine.
I'm sure he just asked to go home, and I'm sure they let him.
Yeah.
But
Sure.
But they got it in okay. But the first time they ran the cylinders, they didn't have the force sensors in the loop. And one of my other concerns with why you need the force sensors is if you're going to run two cylinders close to each other, and they're mounted to a common rigid block. So you run the risk of having one cylinder providing more force than the other, and you could bind the system up. You could rack the system.
Oh, yeah, that makes sense.
I don't know if you could put something in compression, but either way, you'd be dumping a lot of energy into fighting.
You're going to break something, and it's probably that thing you're racked against.
Right. So we use the force sensors to balance loads between adjacent upstage, downstage cylinders.
Cool.
But the first time they ran it, they had the inclinometer wired up, which is good, but they didn't have the force sensors wired up. They bowed one of the cylinders.
Oh, no.
The rod bowed out 3 feet.
Holy crap.
And they
I mean, you're 87 feet long, so I'm guessing it took it, but...
Well, that's just it. They said, Steve, we bowed the rod out 3 feet. Well, how long was the exposed cylinder? And that's the other thing. If the rod
78.
bowed,
Yeah.
if the rod bows, then if this is your cylinder, the cylinder wants to pivot in its spherical joint, which I'm sure it did. Thank goodness for that. But otherwise,
Absolutely.
the over constraint could have ruined the seals.
Yeah, that makes a lot of sense.
So we did the math and we said, you know what? A 3-foot deflection and a 72-foot long steel rod.
2 foot. Okay.
You don't actually yield the material. It's fine.
Lucky.
They said, well, what about fatigue? It's like,
Don't worry about that.
They don't actually see a fatigue load.
Wait, actually?
Well, the thing is,
I mean, it's only one, I guess.
You see 75,000 pounds of tension in them on average.
Yeah.
The plus or minus is friction in the system.
So fatigue, just for the listeners, that's like when you like stress a paperclip over.
Yeah, well, if you take a soda can and you bend it back and forth a dozen times, the material will start to
crack. Yeah,
right.
Makes sense.
But and if you take an aluminum rod and bend it back and forth, eventually it'll heat up and then it'll yield.
And steel is less susceptible to that, but still somewhat.
Right, steel has a much higher rating, and steel actually there's a limit to the fatigue. So you can say, okay, I've got a steel piece and I'm going to bend it, and it's good for 36 ksi or 50 ksi yield, but the fatigue is down, I think, in the range of, unless I'm thinking aluminum, like 21 ksi for
I'll take your
steel,
word for it.
unwelded, clean surface. I can check my books if someone wants to challenge me.
Yeah.
But
bring it up in the comments. Steve's email
is
is
for shit, and welded aluminum is even worse. But because the rods are normally in a constant state of 75,000 pounds of tension, the variation is only 5 or 10 or maybe 15,000 pounds because of acceleration of the platform, which is low. The platform weighs 300,000 pounds. we don't accelerate it at more than 10% G, and I doubt we even do that because it's so monstrous. So 10% G on 30,000 is 300,000 is 30,000. Divide by 4, it's 7,500 pounds of variation. That's 50. Again, the 75,000 isn't your fatigue range. Your fatigue range is like 30,000, and the numbers work out, not an issue.
Cool.
And the bending, the bowing of the rod also did not, that's a strength, not a fatigue issue. That was fine. So
Nice.
they continued to use that cylinder as well.
That's awesome.
But the inclinometer triggered the inclinometer, the linear.
Did you heat treat something that size, or was that untreated steel?
They did a hard coat to the steel.
Okay.
Like nitrided it because they could do that sort of on a local.
They could do that, but they. Oh, I see. In chunks.
5 feet at a time. They
Yeah.
moved it through an oven and poured carbon on it and did magic and whatever. But actually, for the inclinometer, we had string pots for the linear encoders, for the position encoders, for the servo
Where's it
system.
at in terms of position?
So you have an encoder. I can't remember if it was incremental or absolute, with a spool of fishing line or
I've seen those
wire,
stuff in the Field Robotics
spring-loaded.
Center at Carnegie Mellon.
You anchor the spool and you anchor to the floor and you anchor the end of the
But it's
wire.
a rotary encoder, and you're just compensating based on how far out you're pulled for the damage.
Right, and so it's like a fishing reel.
Yeah.
And at some point, with the strings fully extended, they went and painted the system.
Oh no! Oh
And
no!
they painted
the
the
strings.
strings. And then when they went to move the system, they weren't getting the right feedback from one of the strings, and the whole big tube tilted
Ah, crap!
beyond.
So
its
it thought it
2 or
was
3
it
limit.
thought it was not moving, and then it was trying to compensate.
Yeah.
Yeah.
So that triggered the piece. We shattered a bunch of the giant cam followers that were our linear bearings, and the pieces of them fell into the pit.
Oh no! I mean, at least you had all those safety systems, though.
Yeah, but eventually, one of the other. So I mentioned one of the benefits of a force compliance system. One of the other benefits is with a force compliance system is you can, if you implement force compliance properly, you can get an amazingly smooth servo control. I learned about this just by reading years prior, by reading an article about how Disney was using force compliance in some of their animatronics.
Oh, cool.
Because with that force feedback, they were able to get some very lifelike, very smooth, non-robotic motions out of their pieces.
That's like one of the use cases that seems to really make sense for Series Elastic. And I'll be honest, I'm a little bit of a cynic when it comes to that because you lose positional accuracy sometimes.
Mm-hmm. Yeah, so I had read that you could use the force compliant feedback for very smooth motion. I had also used
and you were mentioning oscillations, and I was about to interject, so that's like an overtuned P constant at PID control.
Mm-hmm.
Okay, cool. So I'm tracking.
Yeah. Yeah. So, but I actually, where was it? I first learned about force compliant control at Grumman Aerospace when we were building the Flight Telerobotic Servicer, which was an early attempt to build an android to help assemble the space station.
That's awesome.
It was an overly ambitious project.
What decade would this have been, just out of curiosity?
This was in the mid to late 80s.
Oh, cool. All right. So that would have been...
It was a humanoid robot. Eventually, it was built by... The robot itself was built by Robotics Research.
Cool.
Out of Cincinnati. And
so this is like pre-Robonaut.
What?
This is like pre-Robonaut, but...
This became Robonaut.
Cool.
Robonaut is 100% the descendant of this project.
That's awesome.
And so we went to a company that did a coordinate measuring machine with a 7-axis arm. So it had a roll and pitch joint on each axis, and then capped it off with a final roll joint at the wrist. So we could roll a joint at the wrist. No, I'm kidding.
That's funny.
And they had they had their, because it's a 7 degree of freedom actuator living in a 6 degree of freedom world, as I mentioned before, they had to have some algorithm to, if you wanted to put your end plate where you'd attach your hand.
Yeah.
So if you want to put your end plate in three positions, X, Y, Z, and then 3 positions in roll, pitch, and yaw, you had an extra degree of freedom. The elbow could then be anywhere in the system.
Oh, neat.
Depending on your configuration.
So they had a over-articulated.
Yeah, but it also meant you could avoid obstacles.
Nice.
So if you were, originally they would put a Renishaw probe on the end, on the tool plate, and then they would bring it around and they would, tap the engine block with a Renishaw probe, and they'd have, a point space that they would then use for further analysis.
Yeah.
They had driven axes. The axes were active on this arm, and they used DC brushless motors, harmonic gear trains.
Those are cool.
And then a very stiff torsional diaphragm with strain gauges on the torsional diaphragm, which would then
What's a torsional diaphragm in this context?
Basically, where you have the end stage of your harmonic gearbox has to tie in to the next.
And the harmonic gearbox, that's like that thing that looks kind of like it's like a hollowed out gear. It's like
it's like a garbage can.
And then you get silly ratios. It's
with
like
an oval piece running in it.
It's like 2,000 to 1 or something silly on those, or maybe 200 to 1.
Yeah, I don't know that you can get them lower than 100 to 1. They're insane. So whatever is your output side of the harmonic gearbox has to tie into the piece that it's rotating.
I'll edit that in.
Moving.
Yeah.
So let's say that you have a plate that ties from the output phase of the harmonic drive to whatever is being driven, like a car tire. So you have this the steel that spreads from the hub of the car tire to the rubber.
Yeah.
That's a torsional diaphragm.
Okay,
and if
cool.
you put strain gauges on that
something
diaphragm,
that can kind of twist a little bit and not move both things.
Right. It's very stiff, and you're relying on the fact that the strain gauges are very sensitive to small amounts of strain.
Okay.
So it's a very stiff spring, still a spring, but a very stiff spring.
With not a whole lot of deflection allowed for, or else it's going to deform.
So you measure the deformation, you know how much force is into the system, and you play that back into your system. So with these arms, when you're moving the arm, if the elbow bumps, the additional force that you feel at the elbow folds back into the servo loop, and the system knows to stop pushing.
That's cool.
And it waits until that obstacle is removed. It's a simple common equivalent would be adaptive cruise control.
Yeah, that's awesome.
If you set your cruise control for 70 and some schmuck pulls in front of you doing 50,
happens all the time.
Your car will now slow down to accommodate the guy in front of you.
Yeah.
And then once the guy's out of the way, your car will speed back up. That's the same effect that the force compliance had in the system.
That's cool.
But what we also found with Ka, which I knew it would give us this, again from the animatronics reference, is it would smooth our motion.
Nice.
So Ka, the main stage, eventually called the Sandcliff deck at Ka, with these giant force-controlled linear actuators for the vertical axis, 4 large, but much more, but actually they were off the shelf. They were like 5 or 6 inch bore and 2.5 inch rods and 4 foot stroke, maybe 5 foot stroke. Things that you could buy from the catalog, large, but from the catalog.
What were these doing?
Like 4 of those. These are for the tilt axis.
Okay, got it.
But so we had force compliance on the tilt cylinders as well. The rotation axis was a 100 horsepower electric motor.
Nice.
An induction motor, an industrial grade motor, which we wrangled into servo
like an
duty.
AC. That's cool.
And we ran it through a 2-stage planetary gearbox. It was when we got it into, and it eventually came into Canada.
What was the ratio on that with the two-stage
I
planetary?
need to remember the name of the company that,
Oh, no worries.
that did this. Tower something. But I got to give them a plug because they did amazing work. But it was also servo control. But the motor itself the motor and gearbox was 7.5 feet long and weighed 3,000 pounds.
That's awesome.
And by the time it was bolted up to the entire assembly, you'd be hard pressed to find it because it's small
Compared to the rest of that crap.
The main deck is 50 feet long, 25 feet wide, and 6 feet thick.
Wow.
It moves up and down a total range of 72 foot 9 inches. It tilts forward 100 degrees.
Wow.
So it can have a 10-inch negative
It can
slope.
dump everything.
10-degree negative slope. So here's the normal playing position. It can go -10 because we wanted to be able to go perfectly vertical and not hit a stop.
Yeah, it makes sense.
And then it can rotate 306. It can rotate infinitely. It has a slip ring in it the size of a friggin' dishwasher.
That's awesome.
Custom made for us by UEA, I think it was, handling industrial grade multi-phase power, video safety.
So that's your induction motors and more.
What?
I said that goes to your induction motors and more stuff than that? Or
Yeah.
what do you pass?
Well, actually, the motor didn't rotate, but there were computers. There were computers in the deck, computers that rotated with the deck that controlled other electronics in the deck.
That's awesome.
There were flipper actuators surrounding the periphery of the deck.
Were you passing any hydraulics?
What?
Were you passing hydraulics or pneumatics through that at all?
No air or fluids at all. All
so everything's
photons
electronic
and
upstream of
electrons.
that.
So we had these flippers surrounding the deck with living hinges, which I don't like, but that's another story. But the flippers pop up, and then the interior volume of the deck is filled with 6 inches of granulated cork. Cork, because it's the sand cliff deck.
But to use actual
It
sand
needs to
would be
look like sand.
a huge mess. Yeah, okay.
And we didn't want to use sand, and because every one of us in the engineering department, everyone in the engineering department at McLaren had read Dune. And because in Dune, when the sandworms move through the sand, they create electrical storms. Whether or not that's true, we realized sand for that reason, as well as you don't want to get sand in the works.
Yeah, I would imagine that would just wreak havoc on every single seal, and then you're going to sand down all sorts of stuff.
God, it would have been a nightmare.
Gearbox.
Plus, we were afraid, because at some point, the flippers fold back down, the entire deck tilts and dumps its load into a series of mini railroad car bins.
That's cool.
That are hidden from the audience's view. So all this sand, or whatever the sand is made of, dumps off the deck. It's beautiful.
Yeah, that's cool.
Into these bins where it's cleaned up and used the next day.
Yeah, I would hope so.
And our biggest fear was if the sand or whatever the material is takes on a static charge, when you dump it, it will repel itself from itself.
Yeah, that makes sense.
And you will get an expanding funnel of shit.
So it's like ionized.
If you dump it and it has a charge, as it falls off, all the parts are going to have the same charge and they will repel, and you'll get a fanning out
Yeah, it makes sense.
of your material. So we found cork.
Nice.
And I later learned
Well, that's easy on everything. I mean, that's a great find.
It was a lot easier. It was a lot more useful. It was a lot easier for the people to deal with. Somebody else with Cobb built a recycling system for the cork.
Oh, cool.
Let's say every week, they run it through this system.
It would just scrub it.
which filters out all the bits and pieces that have fallen into it, eyeglasses, pocket watches, condoms, you name it. And so filters out the big chunks, washes it, cleans it, dries it, and gets it ready for the show.
Like dishwasher meets centrifuge.
They built infrastructure to support our system.
That's cool.
Which I just think is friggin' insane.
Yeah, I mean, that's a huge compliment. I mean, that means it's there to stay.
It makes sense.
Yeah.
So we get all the system together. We have two of the three main axes are force compliant control. The rotational axis is not force compliant. It really didn't need to be, because whenever it's rotating, it's rotating like a monolithic block of whatever.
It's not going anywhere.
But they actually, when we were testing the rotation servo out in the shop up in Canada, they taped a large beam to it, like a 26-foot long beam, and put a pencil taped to the end of the beam, set up a ladder with a piece of paper and a mark on the paper. And then they ran a full 360 and stopped it. 1/4-inch accuracy.
Nice. That's crazy.
They were fine. They were good.
Yeah, that's awesome.
So the parts for the sand cliff deck system came in from two major locations in Canada. The overriding the software for the show came in from England. The servo control software for the hydraulics came from South Carolina. The crossbar came from Canada. The verticals came from a roller coaster company in Utah. The cylinders came from Washington State.
Nice.
The pump, the 5 quantity 125 horsepower hydraulic pumps came from Oregon. There was a bank of accumulators, which I call the accumulator farm, because of the surge requirements of the hydraulic fluid. I did all the math for this and checked out what the Atlantic guys, and they said,
factor of safety on top.
"You got that right, Steve. How'd you do that?" So that's been running with the show ever since. But so the parts came in from, and the deck itself came in from Texas. From
That's cool.
Thompson. Tomcat Trusses did the deck, and it had to be assembled from parts coming from all over the country, controlled from all over the world. This SEW stuff comes in from Germany typically. SEW made the giant 3,000-pound rotation motor.
Nice.
Special custom built 10-foot diameter ring bearing with a gear set on it. The brakes from, I don't even remember where Hilliard Twiflex is from. They're out of England originally.
Yeah.
So all over the world coming in to
That's
be
cool.
assembled.
And you had
for the first time
engineers from
ever.
all those companies coming on site to integrate their stuff.
Yeah.
I'm guessing that's cool.
and wrangled by one of our project managers from McLaren. But how to get assembled in front of the client, which is, you probably know, can be an absolute nightmare.
Yeah, I believe it. I mean, they probably want to interfere.
At one of the meetings, the client says, "Yeah, once your stuff all comes in, you'll have 3 weeks to put it together, or 4 weeks to put it together. Is everyone okay with that?" And everybody sort of said, "No, we're not. You do understand how monstrously large and complicated the system is." So they said, "Well, who wants to sign this piece of paper saying that it's going to take more than 4 months, because we'll just sue you then?"
Liquidated damages.
It's like, gee, thanks, guys. It all worked out.
Oh, geez.
But it all gets hooked up. They work out all the kinks, and they're running the show through a couple of the moves. And the technical director.
How much sleep did you get that month, by the way?
I wasn't out in Vegas.
Okay, cool.
This guy Jay Reichgott was out in Vegas, and I think he was okay, because you can only do so much in a day, and you don't want to start making mistakes like dropping cylinders or bowing piston rods. But
yeah, wonder what would happen.
So they ran it, and they ran it in front of the technical director. And he goes, "Yeah, I got a problem." And so Jay says, "What's the problem?" He goes, it moves too smoothly.
What? How is that a problem?
It moves effortlessly, and it doesn't look like we're moving 300,000 pounds of stuff. It's just floating in space.
What's wrong with that?
And he had a problem with that. And Jay, when Jay told me this, I said, I imagine you told him what I think you're going to tell him, right? He goes, yeah. I said, listen, we can always program it
Correct.
to look like shit
Yeah.
if that's what you want, but we could never go the other way.
Yeah,
So
absolutely
the
right.
force compliance system gave it such a smooth and beautiful move, they changed the storyline of the show to accommodate.
That's cool.
So when the show opens, this 50-foot by 25-foot platform has people sitting on the long side of it with oars, and they're rowing it like it's a giant barge.
Oh, that's cool.
Floating down the Nile River.
Yeah, that's awesome.
And so they take this, the stage itself weighs 80,000 pounds. Fully loaded, it can take a 20,000 pound payload.
Holy crap.
Cirque du Soleil specified the spring rate of
Like
the
4
stage.
cars or more.
Yeah, Cirque du Soleil said your stage can deform no more than such a fraction of an inch fully loaded. And we
Hence 6 feet.
Tomcat Trusses and us
Yeah.
gave them that. We got pretty close to Cirque spec for the deformation of the entire system, which
That's
is
why it was
also
so thick, though. I
insane.
mean, that kind of explains it.
Yeah.
Yeah.
So with an 80,000 pound deck on a 200,000 pound moving structure, that H, they had to come up and float like this.
Yeah,
And it's friggin' amazing.
that's really cool.
Yeah. And at some point later in the show, where they have 100 people running around backstage getting all the pieces set up for the next show, they take the sand cliff deck and they invert it like this. And here's the audience. They set it up like this to the flat face of it, and they have a little pin light here, a little pin light that shines up at the back end of the deck. And they do shadow puppets for 5 minutes. They take the most expensive stage ever produced in the world,
Yeah, from
something
sure.
capable of hundreds of horsepower worth of motion, and they hold it still for 5 minutes, and they do bunnies and moths and butterflies and dogs and
How many audience members do you think appreciate the amount of effort that went into something like that? Like, I would guess not that many.
But to be honest, the fact that they feel comfortable with my tech to use it for a backdrop for a shadow puppet show, I couldn't be happier.
That's cool.
It's because the purpose of all the tech is to help them tell their story. And that's what they need at the moment. And that's exactly what it does. It helps them tell their story.
By the way, can I say, like,
Other times in the show, they're having a massive Matrix movie-like fight on it. It's just such an amazing show. And I was on site at one point. I got to watch the show. I've seen it twice now, but I got to get a backstage tour. First off, they keep that place spotless. It's like a garage for Ferraris and Porsches back there. It's just, the whole environment is
Jay Leno's
absolutely
consulting them.
spotless. Jay Leno's garage.
Yeah.
But the stage, for the most part, is kept flat, and they can move it between stations. So I came in, and it was at a lower station, and there's a floor there, and it meets up with the floor. There's a higher floor, and there's a higher floor. It's like an elevator on an aircraft carrier.
That's cool.
At some point.
But, like, wait, one that can gimbal and roll and...
Yeah, but it can also dump the planes into the sea if it had to.
Yeah, yeah.
And during one of the fight sequences, people jump off of it.
That's cool. You were
They
telling me
jump
about
off this thing into the mist.
that. I think it's in that video, too, with people swinging off
Yeah.
those pegs.
It's like a giant human pachinko machine.
Yeah.
And they leap off of it, fall into the mist, onto airbags and trapeze nets below that they can't even see.
Holy crap, that's got to take some
They're
paper
falling
machinery.
70 feet to a target they cannot see.
That's terrifying.
I imagine the first couple of times it must be, and then
You get used to it. You trust it.
so I was in there, and the stage was set to the lowest floor, lowest station, and the two young women who play the twins, the two young men that are the centerpiece of the central characters of the story, they were just sitting, going over their notes for the day. They're just sitting cross-legged in the middle of this 50 by 25 foot platform, and they're just, no one's around them. They're just going over their notes, and you hear an announcement over the PA system. We're going to bring the sand cliff deck up to position 2. And they just continue doing their stuff. Their entire office environment moved up 20 feet. The floor just
cool.
goes, moves up 20 feet.
Did they keep going? Like, were they still giving notes to each other?
They didn't even budge. They didn't.
I guess that's their job, is not to flinch at that. They can't be afraid of it, or they would suck at their job.
It became their everyday thing. The things that I helped design, somebody's office environment. It's
and they wanted it rickety.
They go to work each day and playing with this giant, insane piece of equipment.
That's so cool.
A friend of mine, Fred Smith, Jay Rushcott took a photo of the system from the back of the house, and just the lighting, the work lights were on, were just perfect. There's a golden glow to the whole thing. They may have been doing a lighting setup, but it's just an absolutely gorgeous shot.
That's awesome.
And sent us the image, and a friend of mine blew it up to probably, a foot and a half by 2 feet, framed it, put it up in his living room.
Yeah.
And whenever I visit, it's like he does not treat it like a shrine. It's not creepy. It really isn't. But sometimes when I come in, I'll just see it there, and I'll just stare at it, and he gets caught up in it, and it's like, what the hell were we thinking to think that we could design such an insane piece of equipment?
That's so cool.
But it's been the show. The show was supposed to run for 10 years. It ran for over 12 years.
That's awesome.
And the only thing that stopped it is
global pandemic.
Is the pandemic.
Yeah.
Now, there were 2 problems that I'm aware of with the show. One is that one of the performers for the battle sequence fell, and unfortunately fell to her death.
That's
because the people who were managing the rigging missed an abrasion point. They have this like chessboard set up. The stage is vertical. There's like a dozen people on the top, a dozen people on the bottom, and they come at each other. And then when they fight, they float off. And it really was like the Matrix, slow motion, exaggerated motion, but
live.
The floor is vertical. But because there's just something weird about us humans. You can watch this vertical floor and the people fighting on the vertical floor, and it stays vertical in your mind, but you very quickly accept it as a horizontal battle sequence.
Holy crap.
You're watching it and you're amazed the way it plays with your perception. But again, to play with your perception like this, they had to create a stage 50 foot long by 25 feet wide, pick it up 72 foot 9 inches in the air, spin it at 2 RPM through infinite rotations, and tilt it 100 degrees.
That's crazy. Well, I've always, my reason for being interested in entertainment was in the first place was seeing that Pink Floyd, The Wall, like when I was a teenager, and just being like, I want to work on stuff like that.
As I mentioned, just to reiterate, the same guy who designed that show designed Ka.
That's awesome. The fact that you got to work with that person, I'm so jealous of you. I mean, that's incredible.
Mm-hmm. He was a sweetheart. I mean, he was a serious guy because he was working on so many projects and so many
I would imagine to get hired by Pink Floyd over and over, and then all that other stuff you would have to be.
Yeah, and then later on, right now I'm not working in entertainment, but the last entertainment company I was at is Tate Towers out of Lidditz, Pennsylvania, right near Lancaster. And
a lot of Amish there.
it's very weird to have such high tech in the middle of Amish country. You have to pass by horses and buggies,
The devil.
on your way to go to a place that just has like a campus full of CNC machines to cut all their stuff up for them.
That's awesome.
But so like a couple of years back, when I was actually still at McLaren, we were the engineers of for Tate Towers. We were like, Tate used a couple of other companies, but I always felt that McLaren was like their go-to group for engineering. Tate did the design, McLaren did the analysis for I think it still is the most recent version of the wall.
I saw that live.
Yeah.
Yeah.
And
you were there setting it up.
We were there setting it up at I think it was the Nassau Coliseum. And
I saw it at
dress
PPG Paints, so that would have been a different showing, but the same stuff.
I think they set up in the Nassau Coliseum because it was a good central location, but that wasn't the site of their first show, if I'm remembering correctly. The first show was Northeast, but not Nassau Coliseum.
Yeah.
I think they eventually returned to Nassau Coliseum, but they did their setup and run through there.
That makes sense.
So we got to sit in at the central on the floor, and within you could throw a joint at the stage and hit it from where we were, and some people did that, not me, of course.
Other people.
But we got to see what everybody calls Pink Floyd, the Roger Waters band, playing the entire show, The Wall, front to back.
That's awesome.
Just for us, there were maybe 50, certainly not more than 100 people in the audience.
And that's a game-changing show. That was like the first real rock opera. Maybe that or Tommy, I'm not sure, but it was one of those for sure.
I got to work on Tommy.
Actually?
I got to work on Tommy the Musical.
That's so cool.
Tommy the Musical started out in La Jolla, California.
Did not know that.
As a sort of off the beaten path show. And they worked out a whole bunch of kinks there. They had some fairly low tech, some middle of the ground tech.
Yeah, it wouldn't have had to be that high tech for Tommy. Like that wasn't really about like crazy spectacle as much as it was about the story.
Yeah, by the time it gets to Broadway, it is.
Yeah?
There was a road, started out La Jolla, then it became a road show.
I have 4 LPs of that. I've never seen the Broadway or gotten into that. This is
and then I think it started in La Jolla, became a road show, then became a Broadway show. It had a decent run, then ended. But the show was about pinball machines and doors. And on Broadway,
if they zoom in on that, there's a tech, haven to be had there.
The pinball machine erupts out of the floor on Broadway.
Actually,
and it's on a giant gimbal, 2-axis gimbal. Plus,
so these guys aren't playing bars anymore. It's like, how rich do you have to be?
So it erupts from the floor and it rocks back and forth, front and back, and rotates, and it does the whole spinny thing.
And Elton John's probably there.
Some poor son of a bitch is holding on to it for dear life and singing live.
Is it Dolce or some other guy?
I know some of the guys from The Who were involved, and I don't know if Dolce was involved.
Didn't he play the original Tommy like in the 70s?
Yeah. But I can't remember who was on it. We can research it later.
Yeah.
But for some reason, because of what was done in the film, they wanted a lot of doors. Even though it's The Who, they wanted a lot of doors on set.
That's interesting.
So the doors would slide out.
Yeah, that's like the go to the door, Tommy, or the mirror. It was a mirror in the movie, right?
Yeah. So the doors would slide out on set, and then the doors would rotate. The doors are on a pivot, so they could swing both ways, sort of like Tommy. And there was a pull attached to hold the door at center. So you push the door open, it swings to center, it latches. But the entire system, the door frame and the door, could rotate around its central axis.
That's cool.
Now, I think at La Jolla, they had what are called, and for all 3 shows, La Jolla, Road Trip, and Broadway, you build a false deck on top of the Broadway stage that you're set up at.
Okay, so
And
you're
the deck would
elevated
be
somewhat, and then all your
6,
tech
8,
sits
10
between the
inches
stage
deep.
and okay.
Right. So you've got a deck like this, and
But you're only 10
that,
inches deep, and you got to fit all that crap. That's interesting.
well, that's just it. We had to fit tunnels in the stage for dogs. You have these. You build these. There's a little slot at the top of the deck, and then it expands out like a subway tunnel, straight run.
Yeah.
Though not always, but mostly straight
Wait,
run.
literal dogs?
Well, they're little wheeled vehicles that are called dogs.
Got it. Okay.
It's a little steel construct, and it's got 4 wheels, and it's got a cable on each end, which goes to shivs, pulleys, goes back to a servo-controlled cable
Probably with a
winch
snatch block.
somewhere in the theater, and so the positions are all servo-controlled, and it's run by Alan Bradley Electronics.
They make
Scenic
really expensive
Technology
stuff.
and everybody, I think, Scenic was strictly an Alan Bradley house, and they really put that stuff to good use.
Yeah, no, it's high-end
So the
stuff.
dogs-
I mean, I've had the privilege
the
of
dogs
working with
move
their
back and
Pixies
forth.
sometimes.
in the deck. Now, for the road show, the tunnels in the deck were large enough. We fit a DC brushless motor, a magnet rotor wound stator, very compact, high torque, high speed, with a Parker, because Parker does everything, as we all know, a right angle Parker gearbox,
Nice.
and then a square receiving hole.
Square.
And yes, like a giant piece of 3/4 inch key stock,
Got it.
high strength steel, 3/4 inch
3/4
key
inch each
stock,
dimension, and then you've
Yeah.
got something that
and
mates
you would
to
have
that.
a 3/4 inch slot in the deck.
Cool.
So you bring the door out, you take this pin, which is a flat steel, the circular steel top, and then a 3/4 inch square piece of high strength
Some
steel.
pack has to locate that during like a set
Yeah.
change. Okay.
So that goes through a square hole in the center of the door, drops through the stage, the slot, which is the track, and then drops into the receiver in the motorized dog.
And then that dog can move like
And then
freely.
the dog moves
So-
left and right across stage.
Okay,
and
one
when the
degree of
motor
freedom.
spins,
2
the
if
door
you count the
rotates.
rotation. Yeah.
Right. Now, of course, you have to whittle away that 3/4 inch key where it passes through the slot, because from corner to corner,
When you
you're
probably
going
want
3/4 of an inch.
some tolerant, like it's not going to be thousandths, because then the person would never get it on there when they're.
Well,
something
the thing
to
is, it's square at the bottom. It's circular
Are you
with a
tapered?
3/4 inch diameter. Then it's square at the top. So you just turn it on a lathe
Okay, cool.
for that central section. Although at one point somebody stood on one of the doors while it was spinning and torqued the key.
Nice.
Just you could see the twist in it, like
Yeah,
somebody's
been
neck in
there.
a bad horror movie.
Yeah.
But that was for the road show, and that was easy. That was easy enough to do. But for Broadway, the thickness of the false deck was smaller. The size of the tunnel was therefore smaller. We could not fit a motor in the tunnels. We could not fit a motor on the dog
just have to go up?
run through the tunnels. So we had to put the motorization in the door itself.
Makes sense.
Yeah, except the way the artist drew the doors, there was zero room.
Motherfucking artists.
So, but one of the fun things about having worked in theater for decades is you learn to, well, you know, we make fun of the art. You know, as entertainment engineers, we make fun of the artists, just like mechanical engineers make fun of electrical engineers.
And electrical engineers make fun of mechanical
make fun
engineers.
of mechanical engineers, and we all make fun of whatever the hell you call the engineer who designs the shitty parking lots that we all have to suffer through these days.
Yeah, civil
Those are the guys
engineers.
who graduated at the bottom of the class. Let's be honest, we know this.
But they've all got PEs. I mean, you're one of a dying breed of mechanical PEs.
Yeah.
Whereas
But,
those guys, everybody and
so-
their mother has one.
So I'm looking at this, and we're trying to figure out how we make these doors spin. So we get some Bishop Wisecover double V wheels. We have a custom built
But you're
gear.
using V-belt for this. You can't locate it at all. You're open loop.
No, we had a gear system. So we had a motor controller from CompuMotor. We had an absolute encoder from CompuMotor.
Where's the
An
encoder
absolute-
mounted? Is that on your door itself so that the V slips, it doesn't screw you?
I feel like I should start drawing stuff here,
Sure. Yeah, absolutely.
and I'll hold it up, and hopefully it'll work out.
For those of you who are still with us, thank you.
Mhm. So here's the door.
It's a little blurry. Maybe you have to put your face behind it. As much as I hate to say that, but it's
Okay, I'm gonna have to de-blur things. Everyone's gonna get to see what a crappy room I have.
we cannot afford the editing to cut that out.
Okay, here we go.
Nice.
So there is the door. Now you can see here, and
So what are those?
here.
What are those squares with X's? Are those the motors?
Those are the motors and electronics for the motors were here.
Okay.
The motor dipped its gear into
And the
a gear
electronics
tube.
include the absolute encoder that you'd mentioned.
The absolute encoder was here,
Got it.
which also tied into the same gear rack.
And because you're
The motor was
decoupled
here.
from that V belt, if the V belt slips, you're not fucked.
No V belt. No V belt.
I thought you said double V.
Wheels, V-shaped wheels.
Got
Bishop
it.
Weiscover makes special wheels with a unique profile that run against a.
Because I pictured a two-stack V belt, but
So this is a Bishop Weiscover wheel set.
oh, cool.
And this is a V. And let's say that the rotational axis is somewhere off here.
Nice. And so that's
So
your motor.
that V sits in the grooves. These bearings are mounted to the base, which does not rotate. No, this
So that's
gear
a
is
dead
mounted to the
shaft,
base.
but that looks like a key up top.
This is just a shaft. That's just a shaft.
Dead
Ignore
shaft.
anything else.
Doesn't do
So
anything.
this,
Just
this
sits
is
there.
mounted to the base. There's a gear on the other side here. There's this V machined into it here.
And that key
These wheels
couples
are
the
part of
door to
upper
the top
piece.
belt. Okay, I think I get
Yeah.
it.
So and then the gear dips down, ties into the gear teeth here. This part is fixed, and then the door spins itself around. So we also had to have a slip ring in here.
Nice.
And
What did you have in the
slip
door that
ring-
needed a slip ring? I guess the
What?
electronics. What do you have in the door that required a slip ring?
All the electronics
Got it.
needed to have a slip ring.
Do you ever have issues with signal integrity with those slip rings? Because I feel like when we're spinning them fast,
I always worry about it. I always worry about
we
it.
use them for power, but we don't use them for signal anymore for that reason.
Yeah, well, the thing is this if you can use an inherently low frequency, low quality signal, then I don't worry. So what we did, because I'd used CompuMotor before for the levitator for Beauty and the Beast, the piece that picks the beast up and spins them around, you can trigger pre-selected, pre-programmed motion profiles that are stored in the CompuMotor electronics.
That's cool.
You just close a bunch of switches in a binary fashion.
Interesting.
Q1, Q2, Q3, Q4, Q5, all that stuff.
And that sets
So
your
we-
state, which sets your subroutine, which is what it's doing. Okay.
Right. So the slip ring carried power, and then it carried 4 or 5
And that's
data
all you got to
lines.
transmit, and you've got some kind of what is it, a debounce on there. You're fine.
Exactly.
Okay.
So you can program in a debounce. You can probably work it with a capacitor or something.
Yep.
So we brought power to the system. The encoder box spoke to the controller box directly. It actually sent its signal over the door frame.
Nice.
It was a big hollow door frame.
Done that before. Yeah.
Yeah.
Of course.
And but actually, so we saw the door frame, and the door frame was nice and slim. And I went to the designer and I said, if you can allow me to fatten up the door frame by an inch or two, and we can cover it with molding so it looks intentional, because intentionality is so important to the design.
That makes
If
sense.
it looks like it was supposed to be like that, you can get away with just about anything.
That's awesome.
And so I said, this is what we want to do. He goes,
You were
"I can
running your
work with
power
that."
to the motor through that. It sounds like
The
That's why
power
you need
comes
that
up
diameter.
through the slip ring.
Yeah.
So the power goes to the control electronics, power goes to the sensor electronics. They talk to each other, and then we have a ground and 4 discrete lines, and then we just count up to 15, and we run our cues. But the funniest thing was, the whole thing is self-contained. So you've got the part that I showed was the extent of it. We had a different type of dog, and what we had was 2 little flip-up parts where you stick a steel blade, a 1/4 inch by 2 inch steel blade, through the fixed base plate of the door and into 2 receivers in the dog, and these blades are actually called knives. You
Cool.
take the knives and you stick them into the dogs.
Nice.
I'll tell you a joke about that in a minute. So
Sure, there's plenty.
in the dark, off in the wings, you pop open the covers, you put the knives, because the door isn't the only thing running on the dogs. Other things run on the dogs. So at some point, the dog is dragged off stage by the servo-controlled winch. They pull the knives up for whatever the hell was on it. There was
And I'm
a
guessing
bed,
the motor
there
for the
was a
winch is off stage, and that's how you get
Right.
away with that.
Audience can't see it.
Yeah.
So they move the bed off to the side. They bring the
Or
door
hear
in,
it.
put the knives in. They have to open a center hatch and then take a special D subminiature connector, a 25-pin D submini
Got it.
connector that I
It's like a
specified
parallel port.
with all sorts of unique contacts on it to handle the power and signal.
Nice.
Because I had worked in aerospace enough to know that I can specify what I want in a D subminiature connector.
Yeah. So you've got fat ass contacts for the power. You've got thin ones for the signal that are gold plated.
Yeah. Plus, I had gigantic asymmetric pip pins, like guide pins, so you could only put it in one way. You had to engage the pins before you could
But
engage
it's
the connector
D-sub, so
cell.
it doesn't want to go. It's trapezoidal, right?
Right. It can only go in one way.
Yeah.
And because you got a bunch of stagehands doing this in the dark with 10 seconds.
But nobody's
to
plugging
do
a
it,
90s printer into it because you've got those.
you got to make it bulletproof. One
Yeah.
of my bosses had a farm up in Vermont, and he basically said, when you design, you need to design stuff like you're designing farm equipment,
Nice.
because that's how it's going to get treated on set, like farm equipment. They're not going to have any respect for your design whatsoever. It better not be delicate.
Nice.
So I made this nuclear bomb-proof connector that would handle the power and signal. So the door. So
And it's
but the
D-sub,
door-
so it's inexpensive. I mean, because you're working for theater. Yeah, makes sense.
Yeah, it was that or go straight to a military connector. So
Which is going to cost them like $300 for the connector.
yeah, this was fine, and they recognized it for being a very butch thing. But here we were testing it in the shop at Scenic. We had a guy who at the time was, he was really good at programming the CompuMotor stuff, better than I was. So he was sitting in a pair of very loose-fitting shorts, unfortunately commando, which is something I'm never going to forget. Hi, Mike. He knows who I'm talking about. And the bottom of the door assembly was sitting on a bunch of apple boxes. Apple boxes being, in this case, 1-foot cubes made out of plywood.
Got it.
And there was nothing below them. It was like a magic trick. He had a connector plugged into the bottom of it, and he had the laptop that controlled the CompuMotor system here. And he goes, okay, I'm going to run Q, because you can control it, you can control it directly from a laptop. You can control it from switch closures.
And this is
Because
all
I'm
just
gonna run
binary sending signals, and like this is the one we're
Yeah.
on. Okay.
So he goes, I'm going to run Q1. And he ran Q1, and he ran all the Qs, and the door spun and went to its locations. And it was working perfectly. It was like 1:30 in the morning because the thing had to ship out the next day. So I'm
Jesus.
exhausted.
Typical.
Sitting in a half.
But you didn't
dark-
do that crap with Ka. Like nobody was pulling those kind of hours.
Maybe they did, but I wasn't there to
Equipment that
experience
cost
it.
way more. Yeah.
So I'm sitting on the floor watching this door, sitting on apple boxes. So it's like the magic trick where the guy goes like this under the floating woman.
Yeah.
There's no mechanism contacting the door, but Mike presses a couple of buttons on his laptop and the door spins. And I'm exhausted and I'm watching this door. I'm going, oh my God, I didn't say it, I thought it, but now I'm saying it. I thought, oh my God, that's amazing. How do they do that? And it's like, schmuck, you did that. You're the one who knows how they did that.
That's hilarious.
But I figure if I can be at a job where I can do things that even amaze me, that's a fun job to have.
I've been there a few times where it's, like the dust settles and you're not as sleep deprived. You're like, how did I do that? Oh, right. Just running at brick walls until they got destroyed with my face all over them.
Yeah. So it's like another time we had these what are called the core wagons for Miss Saigon. This is for a road show for Miss Saigon. Miss Saigon, a lot of times, you've heard me talk about upstage, downstage.
Yeah.
One of the things I learned early on was, what does that mean? What is stage left? What is stage right? So if you're on
From the
stage,
perspective of the stage,
right? If you're on stage facing the audience, in back of me is upstage, in front of me is downstage, towards the audience, towards the house. My left and my right, because I'm on stage, that's stage left and stage right. House left is stage right.
Got it.
House right is stage left.
Yeah.
When I was living up in Cornwall, when I was working at Scenic, we had a really nice house, a big piece of property, and the front yard angled down to the street. My wife at the time, had gone to college for theater, had produced a few plays. Both my kids were involved in stage productions. She and I actually ran a community theater group. So
cool.
When we were talking about the front yard, we would use stage terms: upstage, downstage, stage left, and stage right.
Probably helped a lot.
The kids knew it. The upsetting part was we all knew what we were talking about, and it was just too weird. But the whole upstage, downstage thing is because in the olden days, many stages were raked. They were tilted towards the audience.
Interesting.
Because that way the audience can see everything that's going on.
You got like
behind.
a 5 or a 10-degree cant, probably.
Yeah.
Okay.
The slope, and then I've worked on a few productions that have had a 5-degree, maybe even a 10-degree rake. Miss Saigon had a huge rake. I think it was at least 10 degrees, if not more.
Wow.
Which means that if you have a piece of equipment that moves up and down stage, they have a constant load on it.
Yep.
Whereas if you have a piece that's flat and you move up and down stage.
Downstage toward the audience. Okay.
Downstage is towards the audience. If something breaks free, it will slide off the stage and into their lap. So we had this core wagon, which had a lot of scenery that would get mounted to it and unmounted, and new scenery mounted to it. And the core wagons would come in from off stage to center stage, then they would move up and down stage. The core wagons were 8 foot by 8 foot by 10 inches thick, but they had to move 10 feet down stage.
And they could also traverse
larger than their own footprint, which means I needed to have an intermediate stage between. So there was a dog again that would move left and right, and it had, and it was the core wagons, thank God, were permanently mounted to these dogs. They were high strength steel, massive industrial bolts, and so they would move up and down from a fixed knife, but they'd have to, from their start position, have to move down 10 feet and then come back up.
There's a state change there where you go between traversing left and right to when you go upstage, downstage
we had
and upstage.
What are called triple swivel casters, which are 3 casters on a plate and then a swivel bearing between the plate and the piece.
Got it.
And it really reduces reversing loads.
That's cool.
And it's great for stage elements. You can actually buy them from McMaster Car because they're good for moving dollies and other things.
Yeah, McMaster sells everything.
So we had 4 triple swivel casters in the corners, but we had an intermediate, heavy steel intermediate platform that would move. So if the piece moved down 10 feet, the intermediate platform moved down 5, and then the core wagon moved down 5 with respect to the intermediate platform.
Interesting.
So
you got like linear slides between these things, or like how are you doing?
a giant IKO linear bearing. The
Got it.
bearing block itself was about this big
Nice.
and 2 to 3 inches thick. And we could only fit one of them in, and it had to handle whatever overhanging load.
Holy crap. So totally
The system was
cantilevered
gonna
at
give
10
it.
feet out?
We had a giant, we had an induction style Allen Bradley motor because they would not let me use a DC brushless motor. The motor itself was 8 inches in diameter.
I'm sure.
And I only had 10 inches to work with. So I only
Holy
had like
crap.
an inch and change for structure above the motor.
That is brutal.
So there was this Z-shaped central steel element that the first time we did it was bent half-inch steel, and the second time we reworked it so it was bolted assembly
Probably billet.
with 2 giant linear bearings, one per interface, and then 2 ball screws and a timing belt between the ball screws and a timing belt to the motor. So as the motor spun, it was not even a gearbox in there because the ratios were such that it was a direct drive, 1-to-1. Maybe there's a small ratio, but no gearbox between the motor and the belts and the ball screws. So as you spun the motor, the intermediate stage would move down on the ball screw, and the core wagon versus the intermediate stage would move down on its ball screw,
Oh, cool.
held by that. Cable chains all over the place because the motor moved.
Yeah.
The motor had.
But you only had one motor and you had dual ball screws that were attached,
Yeah.
and so you just go out in each direction.
Yeah. So
Okay.
I designed it, and I looked at it, and it was looking really weird, wonky, I think is the technical term. So
Practical
the
term.
design got to the floor, and they built it, on its back. It looked like a horseshoe crab,
Nice.
8 feet on a side. And the guy who's doing the assembly took a look at it, and he goes, "Sywak, I think you finally lost your mind." He goes, "I don't think this thing is going to work." And I said, "No, this is what happens. The motor spins, it spins to this, it moves that, ball screw moves, the bearings do this, the intermediate part moves, that stays fixed, this moves." I said, it'll work. He goes, "I really don't think so." And I looked at it, and I said, "I think there's a possibility you're right." I said, "It looks good on paper, and I intellectually, I can convince myself that it works. My gut, however, is agreeing with you, but fire it up."
Yeah, of course. Well, and if it makes sense on paper, oftentimes it does work. But there's that thing where your intuition doesn't want to agree.
I'm willing to acknowledge that risk,
Yeah.
that something that looks good on paper might just not work, because otherwise you get too cocksure of yourself, and you're going to get yourself in trouble.
Yep.
But so yeah, my gut was telling me he was right, but intellectually I knew it was good, and it worked.
Nice.
So
That's
but,
awesome.
Yeah, always lots of fun stories, lots of fun challenges. I'm grateful that I guess this September that New York City is getting back to having shows again.
That's awesome.
Knock on wood.
They've been doing comedy for a while. I didn't realize they were just now getting back into Broadway, so that's cool. My parents live there, so I'm happy because that's the reason I moved there.
Yeah, it's funny. I was just cleaning out my dad's house, and he has a box. He has a big shoebox full of playbills.
Nice. I just threw a bunch out because
Probably at least 50, if not over 70 or 80 unique playbills of shows that he and my mom had seen over the years. But again, this is the East End of Nassau County.
Yeah, it makes sense.
So it's easy to get to Manhattan.
Yeah. My parents just got a place at 95th and Madison, so they just see shows all the goddamn time.
Nice.
Yeah, no, it's a bling place, and I'm happy for them that they got it.
Yeah.
But
But
my mom is
I'm grateful
all about the
that
Broadways.
that Krause coming back. Humanity was another fun show, another Cirque show.
Yeah,
It's their softcore porn show.
I've heard that.
Basically burlesque.
Yeah,
And
burlesque feels like softcore porn, though. Let's be
yeah,
honest.
when you do it right.
Yeah.
But that show, it was weird. I realized one day that I had designed every effect on that show. Every
Seriously?
main stage effect I had designed. I might have even designed the structure of the stage.
That's cool.
But there were 3 lifts, and each lift, at least 2 of the lifts, each lift had a sloat. Nobody knows where that word comes from. SLOAT.
Sloat. That's a weird word. I don't know that
It's
one.
if you have a lift, a stage lift. So
Yeah.
you have your stage, you have a hole in the stage, and you have a lift that comes up and fills the hole. But then when the lift goes down,
So is that like what you described for Ka, where you've got those 4 hydraulic rams, except instead of tension, they're in compression with what you're describing?
no,
Okay.
in Ka, there are actually in that deck, there are 3 elevators, 3 circular elevators.
So like the
built
British
into the
lift.
deck. The 3 elevators were designed and built by Scenic, integrated into Tomcat's structure, but only once they all got to Las Vegas. And Timberland is the company in Canada.
But you probably
Show
had to make them in
Canada-
CAD first, at least, right? So I mean, you didn't end up.
Well,
with
that's
a
just it.
total
Everybody
cost of product.
exchanges CAD drawings,
Yeah.
and so you're 99% sure it'll work, but not 100. And that's definitely not 100, and I'll tell you why. But so
Been there.
Timberland does oil rig platforms. Timberland does gigantic steel structures that have dynamic loads to them, mostly just oceans, but also there can be moving components. I went to a hydraulic servo seminar, met a guy from Timberland, got to know him, shook his hand, exchanged business cards, and I said, we don't have anything for you guys now, but I just want to know that you're out there because one day we may call on you. And then like 2 months later, Ka came up and I called him and I said, would you be willing to work on a huge entertainment project for Las Vegas? This is what it's going to look like. And he said yes. And Timberland did all the moving components for the Sand Cliff deck.
That's cool.
The crossbar, the tilt axis, giant spherical bearings, the whole integration of everything. They did an amazing job.
That's
The
awesome.
tatami deck, which is behind it, which is a double drawer slide, was done by a company called Show Canada, or as they say, Show Canada. That's actually
It's in
how they
Montreal.
say it. Show Canada.
Yeah.
I worked with them for like a week up in Canada, and I was taking on the French Canadian accent,
Yeah, of course.
except the head of
It's a
Show
weird
Canada,
goddamn accent. As somebody who speaks a little bit of French, I cannot understand what the fuck people are saying when they're speaking French Canadian.
I forget his name.
I get the
head of
Moroccan
Show
dialect though,
Canada.
which is bizarre. You know.
The head of Show Canada was a former rugby player who would tell stories about how he would beat people up. And I know me, and do I have? No, I don't have his name. But I know myself, and there were many times I would almost slip into the accent. And I'm thinking, if he thinks I'm making fun of his accent, they will never find my body. I will be in a ditch, covered in permafrost, and that will be the end of my story.
Jesus.
But Show Canada did a bunch of amazing projects for McLaren. They did the tatami deck, which was all electric, a giant 125 horsepower motors, giant gearboxes, giant, specifically designed gears and gear racks. So again, this intermediate depth, just like the core wagon. So one motor, but 2 different motors this time. So one motor moves the deck, the intermediate versus the fixed.
Got it.
The other motor moves the actual tatami deck. So it's like a 30 square foot?
Now, was the
that has to
intermediate
move out.
deck manned, or is that purely like a node?
It's
to-
purely structure
Got
and
it.
mechanism. But the tatami is, I think, like 30 feet on a side, and it moves 45 feet. Again, more than its own footprint.
Yeah,
and it's
pretty
got
cool.
a constant negative 10-degree slope.
Yeah,
So it moves downhill and then has to move uphill.
that's awesome.
And if it overshoots, it just skims right off into the audience at high speed and starts taking out people's heads.
Wait, you
so-
don't have a hard stop on that thing?
Hard stops and shock absorbers.
Okay, good. I was gonna say.
And safety systems out the gazoo. So, but Show Canada built the tatami, tested it. The first time they ran it, they stood underneath it. Those crazy friggin' guys.
Like the Russians with their space program.
They showed me a video. They're standing under the deck, and he goes, "This is the first time we are running the tatami deck." With our entire crew standing underneath the tatami deck. And I'm thinking,
you guys
thank
morons.
you. I appreciate the level of trust you have in me. I still would have stood to the side. No offense.
Yeah, of course. I mean, it's a commissioning.
But they ran it. It worked. They broke it down. They shipped it. They assembled it. They ran it. It worked. They handed the keys off to MGM, and they all went home because it's electric. It was all electric. There was no hydraulic nonsense, and it was also all built in.
You probably needed some big ass cable, like double out at least.
Yeah. And we probably used 2 tons of cable chain. Just the plastic, at least 2 tons worth of cable chain for this show.
Yeah. You were referring to like cable tray, like the stuff that
cable chains in cable trays.
Got it.
And the lift axis. The cable chains were like 1 set per side, at least 1 set, and the cross section was like this.
Nice.
Because it handled hydraulic. Yes, it had to handle hydraulics for the tilt axis.
That's awesome.
But there's a scene. One of the pictures that Jay Reichgott took was the tatami deck extended out, 2 apple boxes, and a ladder sitting on the apple boxes for the downstage legs and the stage for the upstage legs, and they were using it to hang lights. They were using our equipment as part of the maintenance equipment.
Or like a forklift more. Like it was like a scissor lift.
To be honest, I was honored by that use. The fact that they trusted our equipment so much that they could think so little of it, to me, is a good sign.
That's awesome.
Yeah. But did Show come? Well, either way. So I designed the slope. You have an opening in the stage that's revealed when the lift is down, and if you're not careful, people can fall into it.
Holy crap.
Because there are no guardrails in the theater.
Okay.
And people have fallen into these things. Hell, I was working on a community theater project, and one of the guys at 45 or 50 years old accidentally walked sideways off the lip of the stage.
Oh, no.
And fell 3 feet to the floor. Now, if there had been an orchestra pit, he could have fallen 10 feet into an orchestra pit. Because there are no handrails on the stage.
What about just kind of shock absorbing pads at the bottom? Like, do they ever?
Sometimes yes, not all the time.
Got it.
So what you have with the slope is it's like a sunroof. Really, it's very much like a sunroof. It drops down and slides out of the way.
Got it.
And there's a mechanism with a little couple levered wheel sets. So with a single actuator, you can cause it to drop and pull out. Then with a single actuator, you push it in and it kicks back into place.
That's cool.
So 3 slots, 3 lifts, and a central turntable. And then within that turntable is the one piece I didn't do. My boss did this one. Was like a 3 or 4 foot diameter inner turntable, just a 4-foot disc. And it would rise up and down and then also turn. But it had to carry a 4-foot diameter bowl full of water with a person gyrating in it.
Holy crap.
So the load on that was immense. So that's the one thing I didn't do. But surrounding it.
And you probably had to build in a crazy factor of safety because of the person's dynamics. Yeah.
Yeah. But surrounding it, we had a 22-foot diameter turntable, which was a steel framework, wood.
Okay, so that's not
covering,
going anywhere. Yeah.
And it was supported on rubber. The deck itself that moved was maybe 2-3 inches thick at the most, supported on rubber wheels. We bolted a timing belt to the periphery of it to create a giant gear, if you would.
I get you.
And then took two spring-loaded, because I'm a big fan of springs in my designs, two spring-loaded timing belt wheels running from a 30 horsepower motor in the basement. So a
And that's
prop
providing
shaft,
your tensioning, or what are those?
we had giant die springs to force the tension of those
Got
wheels
it.
against the drum of the stage, so that in case the stage...
And that's your outer
circumference
race for the
wasn't-
timing belt being received from the drive pulley.
Beg pardon?
What you call the drum, that's essentially your bitch pulley. Like that's your driven pulley.
Well, the turntable itself became the drum, because it had this whole gear on fake gear on the outside, and we drove it with two toothed wheels. One handled the brake and the other one handled the drive.
Cool.
But they were spring loaded to apply a near constant pressure against the side of the deck,
That's awesome.
because the deck was not going to be perfect.
Yeah, of course.
The deck was going to vary by at least plus or minus half an inch. So the spring accommodated that.
Nice.
But the specification from Cirque for the deck was 6 RPM with an 11-foot radius.
What did you actually run
Now-
it at?
What?
What did you actually run it at? Like 6 to the edge?
Well, it was designed to run at 6, but the thing is, when that came to us, I was in the middle of my Ender's Game obsession. And I had designed the battle school.
By the way, I have you to blame for getting me addicted to The Expanse.
That's fine. I'll take that hit. But so I had designed the battle school for the Ender's Game story.
I'm 2 episodes away
one-
from finishing season 5.
Okay. And they're making others. I think they're going to hit all the books. Thank goodness.
That's awesome.
But so my design for the battle school did not get into the movie, although I tried. It did get into the Marvel comics. The Marvel
Oh,
comics
cool.
for Ender's Game has my design of the battle school in it. And
That's
I
pretty
got paid
awesome.
for it too.
Yeah.
But I was figuring out,
Wait, you get a royalty from the Ender's Game comics?
not a royalty, just a flat fee.
Okay, that's pretty awesome.
It's still awesome. I got paid to be a geeky fanboy.
Same with everybody that's ever worked for SpaceX or Tesla.
Yeah. So I had to figure out it's a space station with a rotating habitation ring to provide 1G. So I figured, okay, what are my dimensions? What are my speeds? So I had a spreadsheet to allow me to figure out all sorts of stuff for centripetal force.
That is good.
And then we get the call from Cirque du Soleil for Zumanity. So it's like, dude, I've got the spreadsheet. I run the numbers, and I said, you're going to be running it around 5, I forget the number, but like 5 or 7
But you
miles
knew it.
an
Like
hour.
the point is, it was in your brain by then, so you could just puke it out.
Yeah. So, and I said, the other problem is you're going to see around 15% G trying to throw your guys off the turntable.
So you got 1.15 G?
No, you have 0.15
Got
G
it.
outward.
Okay. Yeah, makes sense.
So I said, and they had to make my math easier and to stay true to the show. They had some very voluptuous people, some very Zoftig people in the show.
Yeah.
So let's say they have a 200-pound person in the show, in excellent shape, mind you, in amazing shape. All of Cirque's people are they're superhuman, all of them.
Yeah, of course.
But they allowed for some larger people for the show. Fine by me, personally.
Yeah.
But a 200-pound person would thereby see a 30-pound force trying to push them off the turntable. 30
So when they're
pounds,
toward the edge, when they're in the middle, they don't experience that, but
Not
they're
as
dizzy,
much,
they're
but
probably gonna
towards the
puke.
edge.
Yeah.
and so they were throwing their performers.
How many
off the
RPMs did you
turntable.
say this was?
What?
How many RPMs did you say this was?
6.
Fuck my life. So they're gonna vomit. I mean, if they're not superhuman, which they are, so they're probably not.
I warned them in advance. I said, this is what's gonna happen. And they said, give us 6 RPM, because they wanted a person to go around once every, what would that be? 6 revolutions per minute, 6 per 60. So once every 10 seconds. Once every 10 seconds for the person to reappear. They eventually slowed it down to a 3 RPM, so once every 20 seconds. And it worked fine. And it's a factor of 4 reduction, so you see 4% G, their guys can survive that and not fall off. The other problem is it becomes a Wim Holst generator,
A what?
static electricity generator.
Okay. Like a Van de Graaff.
A steel plate on rubber wheels being driven by a rubber belt.
Oh, that is like a Van de Graaff.
Yeah. And so it was generating a high static charge. So the performers were being thrown from the edge at about at faster than a walking pace, being thrown at 5 miles an hour or more.
That's hilarious.
With a high static charge, landing and not only having the impact, but discharging.
Holy shit.
So within a day, we had designed a static drain for them. So we were pulling
So
the
you
excess
grounded them when they
electron.
landed, or how did you deal with that?
We had a brass wheel on a Fenner. Fenner has spring-loaded tensioners, the beautiful little things. If you go to the Fenner catalog,
Metallic
you'll
for
see them.
sure. Yeah.
And so we bolted the brass wheel to a bearing to a spring-loaded tensioner and had that pressed against the steel track that the rubber wheels ran against.
So that goes to earth ground. How'd you deal with
and
that?
we just had a big old braid,
Yeah.
and we just drained it that way.
Nice.
and it worked. But when we got Zumanity came first, and then came Ka. So when we got to Ka, we said, listen, you've got this giant rotating device capable of infinite rotation at 2 RPM, and the top surface is plastic. Because the top surface of the Ka deck is a touch panel, like you'd see on a laptop.
Wait, actually?
Yes, it is.
That sounds
it
expensive
ties
as fuck.
into giant 3-color laser projectors at the back of the house.
That you've got to coordinate with the kinematics of that moving deck.
Yes.
Okay.
They had a bunch of guys who had never done that before. They coordinated their motion graphics with the feedback position of the deck in real time.
Wow.
And they ran through a game engine.
Yeah, I believe that.
They ran through a game engine, and they were able to match it perfectly. So when you have a person take a strong step on the deck, or when you have this epic zero gravity battle, and a person,
Resistive.
you see ripples come out from where they land, and the ripples are a projection
Yeah, that's cool.
based on where that person lands, and it's mapped to the rotating
Jesus
deck.
fuck. How much did that cost for that sensor? Like,
Probably another $1 million. The projectors alone were probably $1 million or $1 million each.
that's insane.
So
their whole operating budget was at least 20 million, probably way more than that.
The cost to make the show, the cost to build the show was over $120 million.
Holy crap.
It was expensive as an expensive movie cost back then.
That's insane.
It was almost as much as the movie Titanic.
Yeah, that's what I was thinking in my head.
Yeah. So, but we told the people at Ka, we said, listen, we have experience, and Cirque, if you'll recall, you have this experience too.
But the fact that they built a replica of Titanic for that little amount of money, you know something shady was going on.
I just watched the show. I have a 3D setup at home. I watched the show in 3D.
Nice.
People are angry at James Cameron for being a bit of a tyrant on set. You know what? I don't care. The man puts the money on the screen.
Although you got to admit, I mean, that love story was so goddamn sappy that they ended up with on that. Like,
yeah, he said he sold it to Warner Brothers. He goes, take the Titanic, add Romeo and Juliet, make it in 3D. I'm gonna do this for you. Warner said, go for it. You have to admit, Romeo and Juliet, for all its classical goodness, is sappy.
yeah, very much so.
This love story was actually less sappy, and it actually dealt with class conflict, which
Yeah.
I like to see dealt with.
Fair enough. And you're right about that. And, you know, I hate it, but I don't hate it that much.
I still think there was enough room on the door for Jack, and I still think that Rose was a selfish
She was a fucking
woman.
asshole. Like, she was not a great character.
No. And then spoiler alert, when she drops the diamond off the stern of the ship at the end, it's like when you watch the outtakes, the alternate ending, they see her with the diamond getting ready to drop it, and what's his name Bill Paxton's character begs her not to drop it, and she goes, "Oh, I'm dropping it." He goes, "At least let me hold it, let me touch it." And she lets him touch it, and then she goes, "But now I'm gonna drop it." And it's like, lady, do you have any idea the amount of money involved to get you to this location so you can
Drop the
recover your
Hope
lost
Diamond
emotions?
into the water. Yeah.
The money that went into getting you here so you could die in your sleep after having wonderfully relived this episode
And
of
that
your
horrible
life.
Celine Dion song, and like, I don't know. There's bits of it I don't love, but
Give the guy the goddamn diamond. Let him give you a hug and take it as a tax deduction and just move on. It's like, for the love of
Funny.
Pete. But actually, in the movie, having watched it, they do show in film language that Jack would not have fit on the door. They do show it.
what's the
So
film
that is-
language?
that is put to bed. Jack tries to climb on, and he almost dumps the both of them into the ice
Got
cold
it.
water.
Okay, that makes sense.
So I'm watching, and I'm thinking, you son of a bitch lady, he can fit on the door. Let him on the door. And then he tries to get on the door, and it upends, and they almost get dumped in the water. And he goes,
I gotta die now.
"God damn it, I'm not going to fit on that door." And then somebody swims up to try and get on the door. And the guy, this is in the outtakes, and the guy says, "My God, man, there's enough room on that door for all of us." And he goes, "No, there isn't. Get away. If you come any closer, I'm going to beat you dead."
Leo says that. That's fucking hilarious.
So Cameron establishes that you cannot fit another person on the door.
And I do love the Alien movies, and I mean, there's a bunch of Cameron stuff I'm a big fan of. I don't know, it's just
Yeah.
they just ended up
You
so
know what?
sappy with that.
The
It's
first
difficult.
Alien movie by Ridley Scott was amazing. The second Alien movie by James Cameron was as good as, if not better than, the first. He took a sequel and he used it to tear the arm off the first movie and beat it to death. It was
Like
an
Godfather and
amazing
Back to the
movie.
Future. Yeah.
But Cameron, and the other thing that I love about this guy is, and he admits it, that part of his reason to make Titanic was to get permission to dive the site.
Oh.
Son of a bitch. You can
Yeah, of course.
you can be as big an asshole as you want to be. To have the balls to do that, it's like, I am not worthy. The guy has earned my respect.
Have you seen the show Future Man? There's this great bit with James Cameron in there. It's totally a bit. Like they so it's funny. It's about a guy from present day that ends up, like, people from the future come back and they're like, "You're really good at this video game. You got to fight in our war." And it's like a comedy.
Because they just made a movie like that now with Chris Pratt in it.
It's what's his dick who did the interview? Seth Rogen.
Oh, Seth Rogen?
Yeah, Seth.
Is it a movie or a series?
It's a series. It's on Hulu.
Okay.
Seth Rogen directs it, and it's pretty hilarious. And basically, there's these two people that come from the future that are video game characters, and they'll say video game things. You know, like they'll be fighting in a fight sequence, and the one guy goes, "Crush his nuts." It's like pretty hilarious. And so,
It's on Hulu.
yeah, it's
I
on
can watch
Hulu.
it.
It's all on Hulu. Let me know what you think when you watch it. But like,
Okay.
there's they go to James Cameron's compound in like 2030.
Is
And
it
there's
Dead floating in a jar, or is that's not Future Man? That's
I think that might be a different one, but there's this element called Cameronium that's what allows time travel to be possible. And it's named after James Cameron because he discovered it when he was like oceaneering.
oh god. No, he's an amazing guy. He designed. I'm sure he had help. He designed and built a bespoke deep sea submersible whose sole point is to dive to the deepest point of the ocean, piss on a tree there, and then come back to the surface.
When you say piss on a tree,
Metaphorically, piss on a tree.
got it. So just touch
Not
it and come
actually
back.
piss on a tree, but then come back to the surface. It's built like a knife, and you release it, and it drops like a friggin' stone in the ocean into, I think, the Marianas Trench.
And then just some ballast kicks in, and
And then
how
the
it comes
ballast
back up.
kicks in and it comes back up, but it's built with, walls that are probably, 18-inch thick titanium or
The
whatever
fact
the
that it's
hell it's made.
actuated that way is fascinating. I mean, like,
But he built it just so he could, or
say that he did it.
someone could say that they did the deepest damn dive in the world.
Yeah.
And
You don't build
It's like-
something like that to do anything like articulate or do stuff while you're down there. Yeah.
so, he earned his money. I don't care. He earned his money. And it's just like, people are bitching about Elon Musk and about Jeff Bezos. They earned their money. I think they earned their money more on the backs of people. Well, Bezos, certainly with Amazon.
I used to work for SpaceX, so I remember Musk wasn't the best boss of them all, but
you got to admit he's got foresight.
for sure. No, I mean he's great at what he does. He's got some kind of chutzpah for sure.
Yeah.
And
So if they want to build rocket ships and send people to Mars, there's a lot of great tech that comes out of that,
yeah,
which we all get to benefit from.
absolutely.
I'm okay with that.
I am too.
And if Cameron wants, either directly or indirectly, and if not in the first 5 years, in the next 15 years, sooner or later, I'd rather the tech be developed on fun projects than on warfare.
I mean, that's where a lot of tech does get developed. So
I know. So if you can develop it, building robots to help assemble the space station, that's got my vote.
Fair enough. I can concur with that. Well, I think
Yeah.
that's a good note to end on. You want to call it?
At some point, we should end. This is what happens when we talk, Spencer.
Yeah, no, I mean it's fun. I enjoy hanging out with you, Steve. So yeah, let's call it here. Yeah, hey, thanks for coming, people. If you got this far, God bless you. You're the
God
best.
bless you, everyone.
If you stuck around this long and you like what you've heard, please give us a like and smash that subscribe button, or smash that like button and give us a subscribe. We're always looking for new and interesting people to have on the show. If you know anyone good, send an email to podcast@ska.solutions or leave a comment below. Thanks again for listening, and please come to the next one.